Derivative of 5x minus 1 log of 5x minus 1 times 5x. Okay. So differentiate, then we'll form a statement of it. Alright, just like here, in fact, you might see the similarities between this one and that one. This one is just this with chain rule added in. It's almost exactly, can you see the format? Okay, so let's give it a go. Our working should really mirror what's going on here. That's why I wanted to put this on the board. So here you got your product rule happening. Yeah, so I'm going to write v u dash, yep, plus u. Now v dash here is 5 on 5x minus 1. Isn't it? 5 on 5x minus 1. So that's where the cancelling is going to happen. Then this minus 5x just becomes a minus 5. Okay. So now what you've got here, is that where the problems were? First line, yes. Okay. What cancels that? So here you've got 5 log 5x minus 1. Cancel, 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 cancel. Okay? So therefore the statement that I would form, you could form it a couple of different ways. If I just wanted to integrate that, the integral will say log 5x minus 1. Okay? So I'm taking that 5 out. So that means it's going to be this with a 1/5 out the front. So 5x minus 1 log 5x minus 1 minus 5x plus constant. Okay? So can you see, because I divided this by 5, I divided this by 5, and that's what I get. Okay? Now, let's see if we can generalize. Think about where all the numbers came from and how they affected what we had here. Okay? So if I were to say log of ax plus b, okay, where did the 1/5 come from? That was the coefficient of x, wasn't it? Right? That's why it came out the front, because of chain rule. Okay? So therefore here I'll have 1 over a instead. 1 over a. Now all of these things, they're very, very simple. The 5x minus 1, that is the ax plus b that I've just introduced. Right? Log of ax plus b. Now this minus 5x, why did I have it there? It was here to cancel out this term. So what I needed to be is to match up with that constant that I'll get up there, which comes from that coefficient, which is just a. Plus my constant. Okay? Now, like I said, these are kind of a bit long and awkward, okay? Which is why you'll get them as differentiate, hence integrate questions. They won't tell you this. They won't say, there you go, integrate that. Good luck, buddy. You know, they'll give you that kind of clue, right? It's not a standard integral. Though you can see the way that it forms. Okay? Last one, this is pretty simple. The derivative of log of x to the power of 7. Okay? This is simple chain rule. Simple chain rule. Let's do the outside first. What do? It's something to the power of 7. Power comes out the front, and then the power reduces by 1. Okay? We did the outside, let's do the inside now, which is 1 over x, so I'll just shut that on the bottom. Okay. So what integral would you form off that? Well, again, I'll write it without the constant over here. So if I were to integrate log x, all to the power of 6 on x, with respect to x. Right? So what I've done is I've divided by 7, so I'll divide this by 7 as well. Log 7 on 7. That should look familiar, shouldn't it? Right? In fact, it's just like the rule for integrating powers. The crucial difference is there's an x down there to compensate for the fact that you've got log x in there. Okay? So let's just quickly generalize. If I were to integrate log x to the power of n over x. Okay? What's going to happen? It's just like powers, isn't it? The power is going to go up, and then you'll divide by the new power. So when the power goes up, you'll get n plus 1. And if I'm dividing through by that, that's the denominator.